Hello everybody, welcome to the video. Today we're going to be going over how to solve exponential equations using logarithms. So we're going to be solving equations where the variable is in the exponent. So as a reminder, you should know how to go from exponent form of an equation to log form. So the equations that we're going to be working with today are going to look like this, and we want to basically get it from this to this in order to get x by itself. So remember, a is the base right here and it goes down here. B would be this number, and that goes inside the parentheses, and x would be the exponent, and that goes by itself right here in log form, okay? Another thing I mentioned in the earlier video was going from log to exponent form. You can think about it like the snail shell method, so like a to the x equals b, a to the x equals b. You got your exponent form right there. Okay, so let's go over our first example. We have 6 times 13 to the power of x minus 3 equals 63, and we need to solve for the variable, okay? So notice that the variable is in the exponent, so this is an exponential equation, so we have to use logarithms in order to solve this equation. So the first thing that you should realize is that this part of the equation right here is the exponential part, okay? 13 to the power of x. So that is what we need to get by itself. So we start by doing some algebra. We add 3 to both sides, and we get this expression. And then remember, we need the 13 to the power of x by itself. So what we have to do is divide both sides by 6, and then we'll get 13 to the power of x is equal to 11. So this is the equation in exponent form. So our a is 13 and our b is 11, so we change it to log form, which looks like this, log base 13 of 11, and then we're going to type that into our calculator by changing it to log of 11 divided by log of 13. Make sure to watch my last video about how to do that. So when you type into the calculator, you should get that that's approximately equal to 0.935, okay, so that's going to be our solution. All right, so remember, we want the exponential part by itself first, so it's in the form a to the x equals b. Then we change it to log form, and then we would get our solution. Okay, everybody, one more example here. So we have 13 raised to the 2v minus 9 plus 1 is equal to 8, and we need to solve for the variable, okay? We need to solve for v. So remember, we need the exponential part by itself first, and this is the exponential part, okay? So it's 13 to the power of 2v minus 9. So we have to get that part by itself. So we do some algebra, we subtract 1 from both sides, okay? We get that. And now it's an exponential form, okay? Our a is 13, our b is 7, and our x would be the exponent here, 2v minus 9. So we can change it to log form. That looks like this. Log base 13 of 7 is equal to 2v minus 9. So then what we need to do is, of course, solve for the variable. So we would need to just add 9 to both sides, like this. Divide both sides by 2. And then we basically get an expression for v, okay? It's going to be log base 13 of 7, which is some decimal, plus 9 divided by 2, okay? So first thing you should do to figure out what v is, to figure out what the decimal is figure out what log base 13 of 7 is, okay? So we type that into our calculator, and we get 0.759. And then we add that decimal to 9, divide by 2, and then we get our answer of 4.879. So that is our solution. So once again, we get the exponential part by itself first. When the exponent is not just x, when it's a expression like this, then all you have to do is just put it by itself in the equation, and then use algebra to solve for the variable.